Hello everyone, welcome to lesson 1-1. Now for those of you that don't know, when I say lesson 1-1, I mean chapter 1, lesson 1. Rational numbers. While talking about rational numbers, we'll use words such as repeating decimals and terminating decimals. Let's start by identifying what a rational number is, or what rational numbers are. So you can see here that a rational number, right, can be a percent, it can be a decimal, it can be a fraction, or a mixed number. So what is a rational number? Define in your own words. Here we can see that it says numbers that can be written as a comparison of two integers expressed as a fraction are called rational numbers. Now, any fraction can be a rational number, or a comparison of two integers, which means a ratio could be, okay, and then essentially every integer is also a rational number. So let's write a quick definition. So a rational number is a number that can be written as a ratio. It can be a fraction, a percent, a repeating or terminating decimal, or a mixed number. Now, what do I mean by, I had to be specific when I talk about the decimal. I said repeating or terminating. If you have a number that goes into the decimal place and it never ends and the number continues on, such as pi, that is called an irrational number. The root of the word rational is ratio. Describe the relationship between rational numbers and ratios. Simply put, rational numbers can be written as ratios. For example, a rational number is part of a whole expressed as a fraction, a decimal, or a percent. You can have, for every one apple that you have, your friend will have 2 oranges. So there we go. That's a ratio. You can also write it like that. Okay. It can be part of a number. It can be comparing two different numbers. It can be written as a decimal. So I have 50% of the apples that you have of oranges. All those are rational numbers, or 0.5, correct? Okay, let's look at a real-world example. During a recent regular season, a Texas Ranger baseball player had 126 hits and was at bat 399 times. So he hit the ball 126 times out of 399 times. Write a fraction in simplest form to represent the ratio of the number of hits to the number of at-bats. So by simply comparing the number of hits to the total number of bats, okay, we are writing a ratio, okay, and this ratio can help us write a fraction. We have 126 out of 399. So it would look like this. Now we have to simplify it, and we can check to see if both of these numbers are divisible by 3. Divisibility rule to see if something is divisible by 3 is we simply find the sum of all the numbers and see if you get a multiple of 3. So for example, here we have 1 plus 2 is 3 plus 6 is 9. So 9 is a multiple of 3. That's divisible by 3. And then we have 9 plus 9 is 18 plus 3 is 21. That's also a multiple of 3. So both these numbers are divisible by 3. I'm going to make my way around to my final answer, but when I divide 126 divided by 3, I get 42. And when I divide 399 divided by 3, I get 133, right? We can check again. Now, this number over here is divisible by 2 and by 3, right? Because it's an even number, so we know it's divisible by 2. But when we add 4 and 2 together, we get 6, and that's a multiple of 3. Over here we have 1 plus 3 is 4 plus 3 is 7. No, 7 is not a multiple of 3, so that cannot be divided by 3. So I think this is the simplest form that we're going to have. So our answer will be 42 out of 133. So he hit 42 balls out of every 133 times at bat. Oh, wait, I just noticed that if I actually divide them both by 7, I would have 6 on the top, right? Because 42 divided by 7 is 6. And 133 divided by 7 is 19. That's the simplest form. So 6 hits for every at bat, or 19 times at bat. Okay, and here's our key concept. So this is the main lesson. If you're going to walk away with anything, it's this. So what is a rational number? A rational number is a number that can be written as the ratio of two integers in which the denominator is not zero, because anything divided by zero will be zero, right? So we have AB, where A and B are integers and B cannot equal zero. And let's look at this graph. The most basic number, which you see here in the middle, are called natural numbers. When we first start counting, if you're counting the number of pencils you have or the number of fingers that you have, you simply start counting by one, right? You say 1, 2, 3, 4, and so on. Those are called natural numbers. Okay? Then we can add whole numbers simply by adding a 0. So now we're counting from 0, 1, 2, 3, 4, 5, and we can add numbers like 10, 20, 30, and so on. But then if you go below 0, you start to get into the negative, and those are called integers. But they're all integers. This is an integer, this is an integer, right? So the circle, or our oval now, it's getting larger and larger, and it's inclusive of everything that's inside of it. Then we start to get in between numbers, right? So like halves and quarters and 3/4 and so on, positive and negative. Okay, so now that is where we start to get into rational numbers, when we include all this plus the integers plus the whole numbers and the natural numbers. They're all considered rational numbers. Let's continue. Every rational number can be expressed as a decimal by dividing the numerator, or the top number, by the denominator, by the bottom number. What do we mean by that? Let's just see. Let's say we have the number 4 over 5, correct? If I want to convert this number into a decimal, I simply divide the 4 divided by the 5. Okay? So really what it would look like is like this. It's 4 divided by 5, correct? How many 5s are in number 4? None, right? So we put a 0 there. So now I move on to the decimal. Now I have the number 40 down here, correct? So how many 5s are in 40? 5 times 8 is 40. So 8. And 40, subtract, is 0. So I'm done. So 4/5 is the same as 0.8. And just the same way we divided that, that's how we can get any of these. So if 1 divided by 2 is 0.5. 2 divided by 5 is 0.4. And 5 divided by 6 is 0.833. The decimal form of a rational number is called a repeating decimal. If the repeating digit is 0, then the decimal is a terminating decimal. This is where I was saying if a decimal doesn't end and it doesn't follow a pattern where it's repeating itself but continues on forever, infinitely, then it's called an irrational number. And we can see that right here. So we have a half, 0.5, and the next number is 0. That means it's a terminating decimal. It ends. There's no need for us to write the zeros because these numbers are not giving us any additional information. It's assumed that when there's no numbers on this direction, that it's simply 0. Over here, 2/5, 0.4, 0, 0, we don't need to write these 0, so we just simply write it as a terminating decimal, 0.4. But 5/6 does not terminate. It continues on as 3, so the 3 would actually be a bar notation. We put a little line above the number to express that that number will continue repeating itself, so it does not terminate. This is considered a repeating decimal. Okay, we have example 1. For the sake of time, please pause the video and follow these steps. You can see how the numerator was divided by the denominator, 5 divided by 8, see, 5 divided by 8, and the steps were followed, okay? So pause now and analyze this example. Okay, if you feel confident and you think you know what you're doing, go ahead and pause the video again and complete A to D on your own. Otherwise, continue watching and see how I do it. If you pause the video, then play it again once you're done to check your answers. Now, there are multiple ways of doing a questionnaire, for example, 3/4. I understand that for me to get a decimal or a percent, it has to be out of 100. Percent means out of 100. And I know that there are 4 25s in 100. So if I were to multiply the bottom by 25, I get 100. 4 times 25 is 100. Whatever you do to the bottom, you must do to the top. So 3 times 25 is 100. So I would get 75 over 100, which is the same thing as, let me write it here for you, 75 over 100, right? Which is the same thing as saying 75%, because it's out of 100 per 100, right? Or if you read it as a fraction, it's 75 hundredths, which means in the number placement, the number would end in the hundredth, you see, in the place value. So here's the units, tenths, hundredths, 75 hundredths. So the number would end there. And that's how you would write it as a decimal. And to do it just as a basic division, you write it out as a division, which is 3 divided by 4 right there, okay? And how many 4s are in 3? None. So we write 0. We add a decimal there and a decimal there. Now it becomes out of 30. Right? How many 4s are in 30? 4 times 7 is 28. I subtract, I get a 2. Right? I bring down another 0 for 20. And then how many 4s are in 20? How many 4s are here in 20? 4 times 5, correct? 4 times 5 is 20, and there we go. Just finish it. So it's 0.75. For B, now we have a negative fraction. Okay. Remember to always add the negative to your answer at the end, but we can work with it as if they're both positive numbers. Just make sure that you include the negative at the end. And a little trick that I've taught my students in the past is if you ever find a fraction that is with a denominator a 9, it's going to be the numerator bar notation. This number will be 0.22222 infinitely. So the repeating decimal. Really, this will be your answers. It's negative 0.2 bar notation. Let's see how I got that. So it's 2 divided by 9, as you see here, right? 2 divided by 9. How many 9s are in 2? None. Right? So we write our 0, we put our decimals, right? And then it becomes 20. So how many 9s are in 20? There's 2 of them, correct? It becomes 18. I subtract and I get a 2 again. So right here you can see that I'm right back where I started. I'm right back here where I started. I bring a 0 down, right? And now it's 20. How many 9s are in 20? 2. So it's 18. 9 times 2 is 18. And you see how it continues to repeat itself? So this is why it's always going to be infinitely 0.22222. So it's just better to not write this one, put a bar notation above it to express that it is going to repeat itself. And that's with any number, any fraction where the denominator is 9. Okay, for C we have a mixed number. You can see that it's 4 and 13 over 25. Okay, many of you know that 25, there are 4 of these in 100 because of the coin that we have, the quarter, right? So if we were to simply multiply that by 4, we would get 100, right? And we'd like to get 100 because we want to work with base 10, 100, or percent or decimal. It's best to work out of 100. And then the same thing would go here. Whatever you do to the bottom, you must do to the top. And then we have, okay, 13 times 4 is 52. So our answer would be 4, right? Our whole number that we have here, decimal 52, because that's the way you would read the fraction. 52 hundredths, 52 in the 100th place. Or you could simply do it where you divide the top divided by the bottom, 13 divided by 25, and that would work as well. And for D, I want to show you another trick. Any number that is over 11, okay, when you have a fraction and the denominator is 11, your decimal will be a repeating decimal in the 100th. So for example, let's say it's 0.23, it will be 0.23232323. So it's bar notation to the 100th place. Let's try it out. So for now we'll set the 3 to the side because that's our whole number, and we really just want to figure out what the fraction is as a decimal. So we have 1 divided by 11, 1 divided by 11. And how many 11s are in 1? 0. So we put our decimal there. And then we add a 0 there. How many 11s are in 10? Again, none. Right? We put a 0 there. And then we put another 0. And how many 11s are in 100? 9, right? 9 times 11 is 99. So we have our 9 there. Right, 99, subtract, we get 1. Where does that put us? That puts us right back to where we started, right here, with the 1 again. So we add the 0, we bring down a 0. How many 11s are in 10? 9. And then we add another 0, 100, 9. So our repeating 2 digits is 0, 9. You see that? So our answer would have to have a bar notation there, because it's going to continue to repeat itself as 0.090909. Our answer is 3.09 bar notation. Now let's try this in a real world example. In a recent season, NASCAR driver Jimmy Johnson won 6 of the 36 total races held. To the nearest thousandth, find the part of races he won. So, write this as a decimal, correct? They're asking a decimal. Thousand, it's a decimal. So it looks like we have 6 out of 36, correct? We have 6 out of 36. The way I would continue from here, now that we've identified the ratio, 6 races, 1 out of 36 total races, we would simplify this. Look for a common multiple. So I see here that this multiple of 2, 3, and 6. Over here I have 2, 3, and 6 as well. So I would divide both of these by 6. How many 6s do I have on the top? Only 1. How many 6s in the bottom? 6. So now that I have my basic, these are equal, correct? Now that I have my basic ratio, I can go ahead and solve for it. And you can do it as we've done before by dividing. So I can take 1 divided by 6. And I know that there are no 6s in 1. Okay, what about in 10? Well, there's one of them, right? 6 times 1 is 6. Subtract, I get 4. Bring down a 0. How many 6s are in 40? 6. 6 times 6 is 36. Correct? Oh, sorry, I missed that spot. 36. And it's 4 again. So now that it's 4 again, I realize that I'm stuck here, and this is going to continue to repeat itself. From here to here, I had to multiply it by 6. So it's going to be 0.166666 bar notation. So I would put a bar notation there. So we would say, therefore, these 3 little dots means therefore, Johnson won 1 out of 6, or 0.166 bar notation of the races. For example number 4, we're going to go the other way. Now, instead of writing a fraction into a decimal, we're going to write a decimal as a fraction. And this is simple in the way that if you know your place value, you can start there. So here we have our units, and then tenth, hundredth. So this is 0.4500. 4500. Essentially, we're just writing 45 over 100, the 100th digit, or out of 100. And then you simplify that. You know that based on the divisibility rule, any number that ends in 5 or 0 is divisible by 5. So 45 divided by 5 is 9. And 100 divided by 5 is 20. So it's 9/20ths. And now we have the decimal written as a fraction. Remember how I told you that if you have a 9 in the denominator, your answer will be the numerator in the 10th place bar notation? What I mean by that is this should be 0.5 bar notation, right? You see that? This is over 9. For example, if I were to tell you 2 over 9, what would it be? It would be 0.2 bar notation. Do you see how that matches up? See? Well, in this example, you're being shown how that works. Here you have write 0.5 bar notation as a fraction in simplest form. Simply by seeing that it's a single digit bar notation, you should know that it's this number over 9. This would be your numerator, as you can see right there. That's based on memory, but if you really wanted to know the logic behind it, let's follow these steps. So for example, assign a variable to the value 0.5 bar notation. So for example, here we can use n for number. Number equals 0.5555 ... which means repeating, right? Then perform operations on n to determine its fractional value. So n is 0 bar notation, 0.5 bar notation. We're going to multiply each side by 10. The reason is because it's a single digit that starts to repeat in the 10th place. So we multiply each side by 10. We get 10n on this side, 10 times 10 is 10n, and on this side, it will actually move the decimal over. Anytime you multiply a number by 10, it makes the number 10 times bigger. One place value to the left larger. So it actually makes it a whole number. You see that? Now we have a whole number. Move the decimal place over. And now we're going to subtract the n equals 0.555 so that we can eliminate the repeating part. So when I have 10n and I take away one of those n's, I'm going to have 9n, correct? Because I have 10 of them, take away one, now I have 9 n's. And on this side, simply subtracting the 5555. You see that? So what do I have left? I have 9n equals 5. And I can isolate the variable, as we've done in the past. And on this side, 9n is multiplication. So if I bring the 9 over to the other side, it becomes division. So now it's n equals 5 divided by 9, or 5 ninths. If you feel like that was a lot of information all at once, please rewind, watch that again, or pause the video and read through these steps. Okay, let's try with these last two examples. Remember how I mentioned that if you have a negative, you can act as if this is a positive number, and then just make sure that you include the negative to your answer, okay, because it's a negative number. Let's see, this number is negative 1400th, right? Because we have the units, the 10th and the 100th, so it's 1400th. So let's write it as 1400th. Negative 1400th, correct? I'll add that at the end. We can see that this is an even number. They're both even. So it can be simplified to 7 at the top, if you divide it by 2, and 50 at the bottom. And that's as much as we're going to be able to simplify it, because 7 is a prime number. So we have negative 7/50th. That was simple. Let's try the bar notation, the 0.27 bar notation. Remember how I mentioned that it would have to be over 9? For example, if you have, I'll just write it up here quickly. 2/9 would be 0.2 bar notation, correct? Well, when you have two of them, 2 bar notations, it's often 0.27 bar notation like that is it would be, 27 over 99. But let's see how we can get that. We'll let n, our variable, represent our bar notation. And remember that because the bar notation goes over both the 2 and the 7, that means the 2 and the 7 are repeating themselves. 2, 7, 2, 7, 2, 7, and we'll continue on. Okay? And because it's in the 100th, now we're going to multiply both sides by 100. Okay? So we're going to multiply both sides like so. And when we do so, we get 100n equals, the decimal place will move over 2 times. You see, for the number of zeros, we'll get 27.27 bar notation. Continuing on. And then we want to subtract our original value up here of n equals 0.27 bar notation. So let's do that. subtract that. Minus n equals negative, not negative, sorry, our notation. Okay. When we subtract it, we get over here 99 n equals 27, right? Because we got rid of this right there. All right, so we're just left with the 27. And now to simplify, we isolate the variable, so we have to invert the operation, bring the 99 over. We have n equals 27 divided by 99. There you have it. Okay, here we have our guided practice. This is how we will start class. And if you are not sure on how to do any of these, please go back to the examples, examples 1 and 2, examples 4 and 6, and so on, okay? Go back to the video. See you in class, everyone.